what does this represent? You have to, the whole key to this question is figuring out what that represents. What does that, that is the summation notation for a what? A what? Riemann sum. What? What's it a summation notation for? Riemann sum, right. What's the width of each? So a Riemann sum is an infinite sum of what? Lots of what? Rectangles, right? Those are a lot of rectangles being added up. In fact, it's an infinite number of rectangles being added together, correct? It's the limit as n goes to infinity. So you plug in 1, you get 1 rectangle. You plug in, you can plug in 2, you get 2 rectangles. You plug in 3, you get 3 rectangles. Everybody with me so far? So what's the width of each of these rectangles? The width is what? 1 over n. Right, exactly. The width is 1 over n. What's the height of each of these rectangles? The square root of what? K over n. Exactly. The square root of k over n. Yes, correct. So let's take a look. It's in a book. It's Reading Rainbow. So we have number 3 here. Where is it? Number 3. Oh, look at that. Oh, fantastic. It even tells you what it's going to be. Look at this. Fantastic. Even hold your hand through the whole thing. So what does it tell you here? Well, if you, it partitions, so delta x, also known as, what did we call it? We didn't call it delta x. What did we call it? The what? The width. That was the width, the delta x. So when you have a Riemann sum, everybody, you have some function going like this, right? And what are you doing? You're breaking it up into rectangles, rectangles, rectangles. You're breaking it up into rectangles. What's the width of each of these? Delta x, delta x, delta x. Right, everybody? Do you remember this? Ring any bells from when you first learned how to integrate, right? Okay, so if you actually were to list out the x coordinates, so when you plug these in, look what happens here. If the interval from 0 to 1 is partitioned into n subintervals, then each one has a width of 1 over n, and their x coordinates are 0 over n, 1 over n, 2 over n, k over n, all the way up to what? N over n. What is n over n simplified to? 1. Therefore, this is the integral from 0 to 1 of some function. You just have to figure out what function it is. You have a big hint. What's the function going to be? That's a pronoun. Can you be more general?
Is it just the k, root k over n times?
Has to, in terms of x, what is it? Just x.
Do you just plug in the x for the k?
That's a question. I'm asking you for an answer. This isn't Jeopardy.
Root x over n?
No, there's no n's involved.
Root k over x?
Okay, so when you're adding all of these up, when you're adding up all of these, again, only one variable. You have the height of each of these rectangles, right? So the height of each of those rectangles, how do you get the height of the rectangle if you have the function? How do you get the height? If you have the x value there, how do you get the height? Exactly. So if this right here represents the first x value, the area of this block right here is going to be what? Delta x, that's the width, times what? F of x1. What's the first x value? Again, we've decided we're partitioning the interval 0 to 1 into n subintervals, and each width is 1 over n. So if this was starting at 0, and you move over 1, so what's this first x value? 1 over n. What's the next x value? 2 over n. What's the next x value? 3 over n. The next one is 4 over n. So those are the x values you are plugging into the function. Can someone tell me what the function is? What's the function? What's being acted upon? When you list these out, what's the first one when k is 1? What is it? 1 over n. Then what are you plugging in? 2 over n. And then what are you plugging in? 3 over n. Those are the input values right here. Those are the input values into what function? The square root function. The only thing that's there that isn't the x value is the square root. The only thing that isn't there that isn't the input value is the square root. So all this really is the integral from 0 to 1 of the square root of x dx. That is the Riemann sum notation in limit form of the integral from 0 to 1 of the square root of x dx. That's it. Because look what happens here, everybody. Let's say we graphed 1 over x, everybody. What does 1 over x look like? It looks like what? Like this right here? You with me so far? Can you at least make non-committal sounds of consciousness? There we go. Thank you. So we're going from x equals 1 to what? Sorry, x equals what? We're starting with, it's n equals, so 1 over n right here, everybody. What's the limit as n goes to infinity of 1 over n? What does that equal? 0. 1 over a bajillion is really close to what? So we're integrating from 0 to x equals 1. So when you break that up into rectangles, again, if you're breaking it up into n rectangles, what's the width of each of these rectangles? 1 over n. And then if you want to get the height of each rectangle, you plug in the x value into the function. And that's not the right function, everybody. What does the square root of x look like, everybody? Can you help me out here so I don't make that mistake? Sideways parabola, like this. You with me so far, everybody? So if we're going to write these rectangles, what does the first rectangle look like? There's the first one, right? There's the second one, and there's the third one, and there's the fourth one, right? What's the area of that first one? That is the square root of 1 over n, depending on how many intervals we have, times the width. What's the width of it? 1 over n. What's the area of the second one right here? The square root of 2 over n times what? 1 over n. Because what's the width stay every single time? What does the width stay every single time? It stays 1 over n. But what's the height of the first one? The square root of 1 over n. What's the height of the second one? The square root of 2 over n. The square root of 3 over n. So what are you adding together, everybody? You are adding together. You ready, everybody? You're adding together 1 over n times, well, the square root of 1 over n times that, plus the square root of 2 over n times 1 over n, plus the square root of 3 over n times what? 1 over n. How do you write this in limit notation? The limit as n goes to infinity of what? The summation of k equals 1 to n of the square root of k over n times 1 over n. So what does this equal? This is the area under the curve from 0 to 1 of the square root of x. That's it. That's all it is. So if you recognize that, all you then have to do is you go back and you say, oh, I just do the actual integral. And what is it? 2/3. This is entirely recognizing that this is just an integral. That's all it is. That's all it is. It's 24. Is it a fun one? We get to jump around a little bit. 24, what is it? Ooh, exciting. We get to jump topics here, huh? We get to really jump topics. 24, like this. Okay, so exciting. The area enclosed by the polar curve, blah, 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 blah. You need to remember how to integrate polar functions. What's the key to remembering how to integrate polar functions? Do you remember? Yeah, so you need the limits of integration for one. And do we have the limits of integration on this one? Sometimes it can be nasty, right, because they can loop back on themselves. On this one, what are the limits of integration? Yeah, so we know we're going from 0 to pi over 2, but then what shapes are we adding together in this integration? Do you remember? I'll give you a hint, not rectangles. Work with this. So what's the only thing we need to figure out? R in terms of theta. What is R in terms of theta? 1 over cosine of 1/2 theta. So what are we looking at here? 1/2 0 to pi over 2 of 1 over cosine squared 1/2 theta d theta. Was this a calculator one or a non-calculator one? Looks like it, probably a non-calculator one. Non-calculator. Nice. So you have to integrate that. How do you go about integrating that by hand? What is 1 over cosine squared? Secant squared. So what do we have here? 1/2 0 to pi over 2 of secant squared 1/2 theta d theta. The derivative of what is secant squared? Tan. Does everybody remember those things? You must know those cold for this exam. You must. You must, you must, you must. So what do we have here? We have to be really careful because it's not secant squared of theta, it's secant squared of what? So what is this going to integrate to? 1/2 times what? Nope. You gotta neutralize the 1/2. You have to neutralize the 1/2.
So, would we put it 2?
Yes. Because you're going to have this, right?
Yeah.
2, right? From what? 0 to? So what cancels immediately? Yay. So what are you looking at here? Tangent of 1/2 theta from 0 to pi over 2. So that's going to be equal to tangent of what? Pi over what? Pi over what? 4 minus tangent of 0. What's tangent of pi over 4?
1.
Uno. What's tangent? Not tangent of theta. What's tangent of 0? 0. So you end up with 1. Is that an answer? It is. Whee! So you need to remember, this might be something to put in your study sheet. You need to remember this. But Umi, I really liked what you said properly. Yes, conditionally convergent. What does that mean? Okay, what does it mean? Okay, so this means that the absolute value, what does it do? The absolute value diverges, but the series as stated, what? Converges. Nice. This just right here diverges as stated. So can we eliminate some of the answers? We can eliminate D and E. Nice. Okay. We eliminate B. Not bad. We're down to A and C. So now we need to know the next one, right? Well, what about this one right here? K squared over k to the 4th is going to get really close to 1 over k squared. So this is like 1 over the harmonic series squared. The harmonic series squared, 1 over k squared, does that converge or diverge? It converges because it's a p series greater than, where the power is greater than 1, right? So this converges as stated, and what happens with the absolute value? It still converges. So is this conditionally convergent? No, because both converge. So look, they give you 3. This is pretty cool. As stated, it diverges, and the absolute value diverges. As stated, it converges, and the absolute value converges. This one is where it gets fun. So what's the answer? Hey, nice, good job. Of e to the x squared dx. But instead of e to the x squared, we need to write that as the what? The Maclaurin approximation, right? So first of all, you have to remember, what is e to the x? It's the nice one, right? What is it? Keeps going, right? So what does e to the x squared equal? 1 plus 4th over 2 factorial plus x to the 6th over 3 factorial, right? So all we're doing, kids, is we're taking this right here and where are we plugging it in? Right there. That's all we're doing right there. So then what do we do? Well, no, you're literally just plugging in x squared for x. That's all you're doing. It's not the elements, it's just the substitution. You with me? So now we're integrating both sides. That's all we're doing, right? So if we integrate both sides, what do we get? X plus x cubed over 3 plus x to the 5th over 5 times 2 factorial plus x to the 7th over 7 times what? 3 factorial. And we're evaluating that from what to what? 0 to 1. Well, plug in 0, thankfully we don't have to deal with nasty fractions for too long. So what do we end up with? 1 plus 1 over 10 plus 1 over what, 42? Is that right? Oh, look, hey, we did it right. Sweet.